Hey there, welcome to this lecture. Now we're going to talk about the popular pattern that's used pretty much everywhere in multi-threading, known as the producer-consumer pattern. And you'll also be introduced to two very important methods known as the wait and notify methods. So I'm just going to go back to this project that we created earlier called Learning Threading. You can create a new project or just go back to that one. And in the source folder, I'm going to right-click and go to New, and I'm going to create a new package. And we can call this package com.jobready.producer-consumer. And it doesn't really matter what name you give it, but that's just a name that I kind of chose on the fly. So right click and go to New Class, and I'm going to create a class called Producer. And just hit Finish, and I'm going to create another class. Right click, go to New Class, and this one is going to be called Consumer. And hit Finish. So we've got the producer and we've got the consumer, and I'm also going to create another class. Right click, go to New, and this is going to be called Application. And this is actually going to have our main method, the starting point for this example. So select it there and just hit Finish. So here in the classes producer, this is actually going to be a thread. So we want to implement runnable. Okay, and hover your mouse and just add the unimplemented method, which is of course the run method. And I'm going to do the same thing for the consumer class. So you can, like I said, threads, I want you to think of them as tasks. So we've got two tasks here. We've got the producer task and we've got the consumer task, and we're going to be executing these tasks in this application class. So again, what is a producer-consumer pattern all about? Well, it's used to separate tasks that need to get done from the actual execution of those tasks. The producer-consumer pattern facilitates, or what's the correct word I'm looking for? Orchestrates, all right? Orchestrates these two tasks to run properly. And it's really a fancy name, you know, the producer-consumer. Don't let it intimidate you. It's quite simple once you realize that almost all work that gets done around you in the real world uses the producer-consumer pattern, right? So for example, at a restaurant, a cook prepares a meal, and once it's ready, the cook places the food on the order shelf. A server then comes up and picks up the food and takes it to serves it to the customers. The cook can be seen as a producer because he is producing the food, whereas the server can be seen as a consumer, okay? Both the cook and the server share a resource, which is the order shelf, right? This is the shelf where the cook is going to place the food on top of. If the order shelf gets filled up, the cook will wait to place more things onto it until the server has removed some dishes off of that table or off of that shelf. Similarly, the server can wait at that shelf if it's empty, right? There's no food on the order shelf, so the server is going to wait there until more dishes are prepared and placed onto that shelf before he gets to do what he's supposed to do, which is serve those dishes. So the code that I have here, the producer and the consumer, we're going to be going over an example to demonstrate the usage of the producer-consumer pattern. And for this example, consider that, you know, we have a website where people ask questions, and those questions need to be answered. So people are, you know, sending us questions left and right, and those questions need to be answered by someone. So we've got two tasks. We've got the reading of questions, and we've got the writing of answers. So the producer is where the questions are being produced. So that could mean, you know, getting the questions that people post on the website, saving them in a database, and, you know, reading it from there. Some task of processing those questions that people are asking. And the consumer is where the questions need to be answered. Let's go to the producer first because, you know, it makes sense for those questions to be produced first. And outside of this run method, I'm actually going to define some attributes of this class. The questions that get asked on the website, we could just say that they get stored into a list, okay? And to make things simple, I'm just going to have these as integers. So we'll just call it question list. okay? And we're going to initialize it to the value of null. So rather than actually coming up with questions, I think it's just easier for us to be dealing with integers. But think of these as question number 1, question number 2, question number 3, and so on. You could do the Control-Shift-O to bring in the list import. And I'm also going to set a limit for the number of questions that get queued up, okay? And that's going to be a final int limit variable, and I'll just set this to be 5. So when we have 5 questions that need to be answered, we're not going to accept any more questions until some of the questions have been answered, and we've made room to allow more questions to be produced. And then I'm also going to create another variable of type int, and we're just going to call this question number. So this producer is going to have a constructor. Just do producer, and it accepts as an argument to it the list of questions. So we'll just call it question list, and we're going to assign that to this question list. And then going down further, I'll have a method for reading the questions. Okay, this is what it all comes down to, is reading a particular question that comes up. So we're going to define a method called read question, and we'll pass in an argument, and this is going to be the question number. And then in the body of this run method, I'm actually going to be calling this read question, but we'll get to that in just a second. So here we can have a while loop that says that if the question list, if its size has reached the limit, then what we want to do is we're just going to print out, questions have piled up, right? So we need to wait for answers, because remember, we can't accept more than 5 questions at a time. So if the question list has reached that size, we're going to print that questions have piled up. But that's not enough. We can't just print this out and say we're waiting. We actually need to tell this thread, because think of this as a task. We need to tell this task to wait. Okay, and the way we do that is we have to call the wait method. And another thing is that this is a shared resource. The question list is actually going to be a shared resource. This same question list is going to be consumed in the consumer when we get to that. So this is a shared resource across the producer and the consumer. It's a shared resource across 2 threads. The producer is going to be adding questions to this list, right? And the consumer is going to be taking those questions off of that list and clearing them away to make room for new questions, okay? So that's the idea. The producer is adding to this list up to the limit of 5, and then it has to wait until the consumer answers those questions and then removes them off of the shared resource called question list. So remember what I told you, when it comes to shared resources, we want to make sure we use the synchronized keyword. So I'm actually going to synchronize this block of code, right? When we're dealing with when we're checking the size of the list, we are actually accessing the list, and we want to make changes to it. We're going to make sure that everything is synchronized. So I'm going to add the synchronized keyword, and synchronize on what? We need to specify the object to lock on. All right, now I can define an object up here. I can just call it object, my object is equal to new object. I could use this object right here and use that as the lock, right? But I'm not going to do that. We have this question list as the shared resource across the producer and the consumer threads. So I'm just going to use this question list object. Why not? Use that inside of this synchronized lock. And I'm going to take this code and dump it into this synchronized block. So after printing that, the questions have piled up, wait for answers, I'm actually literally going to wait. And the way you do that is you can do question list dot wait. All right, this is a special method. It belongs to the object class. That means that every single object that you create, it has a common parent, right? The object class is a common parent of all objects. So this wait method belongs to the object class, and we can actually invoke this method and say that, hey, this question list is, we're waiting. This synchronized block has been put on wait, and we're passing on the control to any other thread that wants to access this question list, okay? And it's giving an error here. Hover your mouse. It's saying we need to, handle the interrupted exception. I'm just gonna add that to the throws declaration, and we're gonna let something else handle this exception if this method ends up throwing that interrupted exception. So this is just checking for whether the size has reached its limit, and then it's gonna wait until it gets notified to continue. Okay, so it's going to wait until it gets notified. So it's looking for some kind of notification. I'm going to explain to you in just a second how that works. But outside of this, I'm going to have another synchronized block that is going to be adding a new question to the list. So we're going to use the same block object, which is going to be the question list itself. And we could just, do a system.println and say, we've got a new question. And I'm just going to add the question number as part of this sentence that gets printed to the console. And then the real work actually gets done here. We're going to add this question to the question list. So we could just do add and then give the question number like that. And again, the question number is right here. That's being passed to, as part of the argument to this read question method. And we're going to be invoking this read question here in the run method in just a second. So after the question has been added, I just want the thread to sleep for just 100 milliseconds or so, just so that it doesn't immediately, add everything in one shot. It's going to be very quick. So I just want to slow it down a bit to make it a more practical example. And then after that, I want to notify that the question has been added to the question list. And how do you do that? Well, we're just going to do question list.notify. And what this is going to do is it's going to notify the threads that are waiting, all right, that are waiting for the notification that they should wake up. And that's what this notify method does. It wakes up those threads that are waiting so that those threads can continue processing. It relinquishes the control on this question list object. So these wait and notify, these are two new methods that I introduced you in this lecture. And these are used to do exactly what they sound like, right? If you want to pass control to another block of code, you use the .wait. Now, this is the interesting part. This producer is a thread, okay? That's how I want you to think of it. It's a task, it's a thread. You can think of it as a thread. Now, and we're telling this thread to wait on this question list object. So what happens next? Well, another thread is going to take over. And what is that other thread? Well, that's the consumer thread. So at this point, when we call this wait, we've reached the limit. The number of questions have piled up in the question list, and we can't really add more questions to it. So some other thread is going to come in and answer those questions. And then I'll show you how to do that in the consumer. It's going to answer the question and remove that question out of the question list to make room. And then as part of that, it's going to notify that, hey, the other thread can take over now. I'm done doing what I'm doing. So we'll look at that in just a moment when we work on the consumer task. But this producer task, when it's reached its limit, it's pretty much done and waiting for the questions to be removed off of that list. So if it's confusing at this moment, don't worry. It's going to make a lot more sense when I work on the consumer, and you'll be able to connect the dots together. There's also a notify all method that's used to notify all the threads that may be waiting. But we're just going to stick with the one that is related to this question list. Anything that is waiting for this question list lock to be released is going to be notified. And it's also important to realize that this wait and notify method can only be called inside of a synchronized block. Okay, so just keep that in mind. So there we go. We're done with the read question method. And this is part of the producer, right? We're really producing the questions here. And we don't need this object anymore. I'm just going to get rid of that. And in the run method now, we're actually going to invoke read question. and I'm going to increment question number. So after this question number has been passed to read question, it's going to increment it because of these two plus signs. It throws an interrupted exception, so I'm just going to surround that with a try catch. Let's just get rid of this, the code inside of the catch. We don't need that. And we don't want this just to run once. We're just going to surround this with a while loop so that it does this indefinitely. So this try and catch block, I'm just going to cut that out and paste it inside of the while loop, so this continues to happen until we close our program. So it's going to continuously create questions or produce questions. That's what this guy does, the producer. So to save time, I'm just going to pretty much copy all of this code and dump it into the producer. But we're going to have to rename a few things and fix it up, so not a big deal. We'll do that quickly. So this class is, of course, the consumer class, and the constructor should be named appropriately. And we don't need these this final int or this question number variable as part of the class. We do need this question list because that's the same list that's going to be shared across the consumer and the producer, and that's passed into the constructor of the producer as well as the consumer, and I'll show you how to do that in the application class when we get there. Now this is, of course, we're not going to be reading the question. Here we're going to be answering the question. This is the consumer. So the producer, creates the questions, right, or reads questions that people are submitting or whatever, and the consumer is going to answer those questions. So we're going to just type in answer question, and it's still going to be a synchronized block on the question list. And I'm going to change this to question list. If it's empty, we can use the isEmpty method. If the question list is empty, I'm going to print out that no questions to answer, waiting for producer to get questions. Okay, and we're just going to wait here. So again, what is it going to wait on? Well, it's going to wait. So again, what is this wait really? So again, what does the wait mean at this point? Well, it's going to wait because the question list is empty. It needs to be populated. So new questions need to come into this list. So that's why we put this on wait, so that some other thread that is responsible for populating that question list can do its job. So in here, right at the start, I'm just going to do a thread.sleep. And it takes longer to answer questions than it is to produce them, right? So let's just say we have simple yes, no answers, and we're just gonna sleep for 5 seconds to simulate that it takes about 5 seconds to answer a question. And then I'm gonna print to the console here, we're just gonna call it answered question. And then what I'm gonna do is I'm going to do a question list.remove and remove the question at the 0th index position. The remove method of a list doesn't only just remove something from the list, it also returns that value. Whatever it is, it returns it, and that's why we'll also be able to print that removed value as part of this print line statement. And we're removing those things from the 0th index position. So what does that mean? That means that we're always removing things from the front of the list. And this kind of simulates a queue, right? Like if you're in a line, let's say at a grocery store, you're in front of that line. So you should be removed from that line first, right? And that's the same idea here. Think of this as a queue. We're removing the first element in that list because it is, the oldest element. That was the first element that was put into the list, and it gets removed. And that's how we proceed in getting rid of all of the questions that need to be answered in the order in which they were inserted into that list. And here we're not producing any questions, so I'm just going to get rid of this. The next line is the notify method. So we need to notify the threads that are waiting, okay? So the consumer is about answering questions, right? That's what this method does. This method answers the question. So it runs in its own thread. The consumer will have its own thread, and the producer will have its own thread. So this notify method is going to notify that, hey, we've just answered a question. And so the thread that was waiting can now resume. And that, of course, is going to be on the producer side. So the consumer here is going to notify the producer that, hey, I've answered the question. So two threads running, producer and consumer. And you're going to see in just a second when I call upon both of these threads and start them in the application class, which we'll get to in just a second. And then in the run method, this is the execution of the task, right, for this multi-threaded application. So the consumer is the task, and we're defining what the task is supposed to be in this method called answer question. So we're gonna invoke that answer question here instead of read question, and this is not going to have any argument. We shouldn't need an argument to answer the question here. Let's get rid of this one. So we've got the producer, which is producing the questions, and we've got a consumer, which is answering those questions. Now in the application class, right in our main thread, I'm just going to initialize an array list, and we could just call this could be just a list of integers. Again, I didn't use sentences or strings to save time. I don't want to be typing up random questions here. Let's just think of these as a list of questions, and we're just treating them as integers. And I'm going to call it question list is equal to new array list of type integer. And just do the Control-Shift-O to bring in the array list from the java.util. And then we're going to have two threads. So the first thread, we'll call it T1, is a new thread. And as an argument to this, we're going to pass in the producer. So we're going to create an instance of the producer. We're going to do new producer and pass in the question list object. Okay, so this question list is being created here in the main method. And that same question list is going to be passed in the producer as well as the consumer. So I'm just going to copy the same line of code and paste it down here. This is going to be T2. And instead of producer, this is actually going to be consumer. So we're passing the same list of questions, to the same list, the same data structure, the shared data structure to the producer, which is going to populate that question list. And then the consumer is going to have access to that same list and be able to remove those questions from the list. So we got T1 and T2, two separate threads, each responsible for doing separate work. But there's a shared data here, which is a question list. And then to start this application, I'm going to do t1.start. That starts the first thread, and t2.start, and that starts the second thread. So now if I hit play, you can see how things are printed out here. So there we go. We've got new question 0, 1, 2, 3, and then we've also been able to answer the question. So these lines are being produced. This is coming from the producer, and this is coming from the consumer. Okay, the consumer is answering the question. The producer is producing those questions or reading those, from some database or whatever, wherever our questions are being saved on a website or whatever. So here, notice it got to a point where it says no question to answer, waiting for producer to get questions. So once it answered all these questions, the producer hadn't produced any questions yet, so that's why it was waiting for producer, and it relinquished control and gave it over to the producer to produce more questions, and that's what happened here. And here's another example. It's saying questions have piled up, wait for answers. So here the producer wanted to put more questions into this list, this question list, but it was maxed out, right? Remember, our limit was 5 questions. So it tried to put in 5 questions, but it couldn't do that because we have that limit. That's why this is being printed. Questions have piled up, wait for answers. So the consumer should have answered those questions, and once it did, then it moved on to whatever it has to do. So hopefully you get the idea. This is a shared data structure that's being used by the producer and the consumer. The producer adds questions to this question list, and the consumer removes those questions from the question list and just prints out that those questions have been answered. And inter-thread communication is happening here because we have these wait and notify methods. Okay, so really quickly, if I hover my mouse here on the wait, Notice what it says. It's pretty straightforward. It's saying causes the current thread to wait until another thread invokes the notify method, right? Or the notify all method. These wait and notify do exactly what they sound like. So hopefully you get the idea behind the producer-consumer pattern. It's a pattern that's used to separate tasks from their actual execution, right? So we've got two tasks, the producer and the consumer, and we're separating these two tasks, and we're using this shared list, which you can think of this as the list of orders that need to be executed, or the list of whatever tasks that need to be completed. That could be in this shared list, and one thread could be putting tasks onto this list, while another thread is removing those tasks from that list when it completes those tasks. So you can think of this question list as a container to store the things that need to get done. And these two, the producer and the consumer, takes care of those things. One of them is generating those things and inserting them onto this list, and the other one is taking them off of that list. And that's how the task's execution is managed using this shared data structure. So this is known as the producer-consumer design pattern, and it's used all over the place in multi-threading. Now we use these this wait and notify methods. These are still primitive approaches to inter-thread communication. I recommend that you kind of stay away from them as much as you can and use concurrent utilities that Java provides. And we're going to get into a data structure in the next lecture that is going to be the concurrent friendly data structure to store tasks that need to be done. Here we're just using an array list to manage that. And not only are we using an array list, it really doesn't suit the kind of work that we're trying to accomplish here. An array list is just, a container to store elements, multiple elements. Order of insertion is maintained with the array list, but the way we're using it here is more of like a queue. So in the next lecture, I'm going to introduce you to a concurrent version of the queue data structure, and it's known as the array blocking queue, and it comes from the java.util.concurrent package, and that will be more correct for this kind of a use case with the producer-consumer pattern, and concurrent friendly, and you won't have to use these wait and notify methods to manage the interaction between two threads or multiple threads. So stay tuned. I'll see you in the next lecture.